We're going to finish up section 4.2 by doing two more problems. All right, so our first one is the set of all polynomials of degree 2 or less a vector space? All right, so as we did in the last video, if it's yes, we have to prove it's true for all 10. If it's no, I just need to give a counterexample. So first, think about it. If you add or do a scalar multiplication by any degree 2 polynomial or any quadratic, will it stay quadratic or smaller? And the answer is yes. So I'm just going to kind of give you a basic showing of this. I'm not going to go through all 10. If I said ax squared plus bx plus c, so that's 1 degree 2, plus another degree 2, so dx squared plus ex plus f. So if I add any two quadratic statements, I would get a plus d times x squared plus b plus e times x plus c plus f. So I would get another degree 2 polynomial. So you would just have to go through and show this is true no matter what order I add them in, no matter if I do the associative. If I add that to 0, which is less than degree 2, I'm fine. I get the original. If I add the opposite, I get 0. I'm good with that. If I multiply by a scalar, it's still degree 2 or less. We're all good. So that one would be a yes. But show all 10 rules. Show all 10 properties. All right, so the reason I wanted to go over that is I want to do a very, very similar one that is different in one very specific way. So our next one is the set of all degree 2 polynomials a vector space? So this is almost the same as the last question. The only difference is I have left out the two words or less. Meaning, if I add any degree 2 polynomials, does it stay degree 2? If I do a scalar times degree 2 polynomials, does it stay degree 2? No matter what case it happens with adding, subtracting, or scalar multiplication, will it stay a degree 2 polynomial? So above, it had to stay degree 2 or less, and that was fine. Well, here, I can come up with a very specific example of where this doesn't work. So this is not going to be a vector space, so I'm going to show a very specific example with numbers. So if I did 2x squared plus 3x plus 4, add that degree 2 polynomial, plus negative 2x squared plus x plus 1. When I add these together, I get 4x plus 5. This is not a degree 2 polynomial. Therefore, it is not a vector space because I added 2 degree 2 polynomials and I did not get another degree 2 polynomial. So you have to be very careful in reading these. Just those two words or less made it, yes, be a vector space. If I get rid of those two words or less, it is not a vector space. All right, we are now done with section 4.2. I will create another video for 4.3.